start to the next talk. We're going to have Martin present. He's been a regular at various Elixir Confs as both an attendee and as a speaker. He has a very extensive collection of libraries that you can all look into and use over at his GitHub account, which would be, I guess, github.com/QQWI. Yeah, he's also an Elixir forum moderator. And without further ado, let's give it up for Martin for his talk, Going Meta with Elixir.
So, welcome everyone. I'll be talking about going meta with Elixir. So, what does it mean to go meta? Well, within the context of programming, meta programming, it means that rather than just writing a program that takes some data as input and transforms this data and performs some tasks as output, it actually treats the program itself as data that it can create and modify while it is running. So in this talk, I'm going to explain to you in what ways Elixir helps you with doing meta programming and why this is useful, and give you a couple of very practical real-life examples. Of course, some of these examples have been trimmed down somewhat, so my code fits on the slides. This talk is geared towards an audience of people who may be new to Elixir or may already know a little bit of Elixir but are new to, for instance, programming with macros. It's not a problem if you cannot follow along with all the code examples that I show you. It will all be very quick because we only have 20 minutes. But I will link to a lot of resources and show you many names of where you can find the stuff that I'm talking about, so you can read about it in more detail. So in Elixir, there are two main techniques that you can use to do meta programming. We can both influence how code is actually being compiled while you're creating your program. And once your program is running, we can also change what code the program itself actually consists of. And this might still sound a little bit vague, but I will explain to you why these two techniques are very useful. So let us first start with running code at compile time. The simplest and most general technique to use to do this is dynamic compilation. If we have an Elixir module, like this simple example here, that has a single function to compute the nth Fibonacci number, then all the part that is inside the function clauses is called at runtime when the program is actually running and someone calls this function. However, all the parts outside of the function are evaluated at compile time, and you can use any Elixir code, including of modules you wrote yourself that have already been compiled, and just call that stuff over here, and it will run at compile time and do all kinds of interesting stuff. As a very simple example, we can just use an if statement to conditionally compile one implementation or another, or use one implementation and raise an error at compile time to explain, hey, you can't use this feature, you cannot use this library because we're missing some very important thing that the underlying runtime should provide. So then that way we can propagate errors, show you errors early during the development cycle, so you get very quick feedback, which is a lot nicer than finding out only once your program is running or once your program is deployed. So let's go back to our Fibonacci example that we used before. Now this is a very naive implementation of the Fibonacci function, and there are some very clever ways to make it faster. But this is a talk about meta programming, so we're going to solve this problem with meta programming. One thing we could do is to pre-calculate a couple of known results to the Fibonacci function, and then use a for loop to iterate over these known results and define function clauses for each of these known results. So now the Fibonacci function does not need to recurse for these simple function calls, and that makes it a lot faster. So writing code like this does exactly the same thing as if we had written this code by hand. But of course, once we're adding more and more stuff to this, this becomes less and less maintainable. As a real-life example, this is how Elixir uses this is how Elixir is able to have proper Unicode support. They take the Unicode data.txt file that is released every couple of months by the Unicode consortium, and they parse this file to find out properties about the various characters, and there are thousands and thousands of them that make up the Unicode standard. And then we iterate over all of these ranges of characters to define, in this case, whether this is a uppercase character or not. And this is a very clear example where you could not maintain this code by writing all these function clauses by hand. Now, if plain dynamic compilation is not good enough, we can also use a more powerful tool, and therefore it also has more limited uses, which is using macros. And macros are functions that, regardless of where they are in your program, they are always evaluated at compile time, and then they disappear. They take their input as code, and they return some new code that is then placed at that location. By default, macros are hygienic. If you've ever used macros elsewhere, you might know that it's really a difficult problem, that you might use a name that's also used in the surrounding context and you get strange name clashes. And in Elixir, this is not the case. Of course, if you really do need a name from a surrounding context, there are ways to reach into that. So macros work on Elixir's abstract syntax tree. Now, what is an abstract syntax tree? Well, if we have some snippet of source code, for instance here, a very simple mathematical expression, then the easiest way to look at this is, of course, as a string. But a string is just a sequence of separate characters, and we don't really know anything about these characters. So we need to parse it ourselves in our macro if we were to receive the input as a string. So instead, we're able to patch into the Elixir parser, and we just receive this already as a parsed expression with proper precedence and resolving the proper names to where the functions actually are, etc. So working with such a tree structure allows us to, for instance, pattern match on only the plus and say, okay, we have these two arguments. I don't care about what the arguments are because I will move them elsewhere without ever touching them, for instance. And here you see an example of what the AST actually looks like as an Elixir data type. If you don't immediately get it, that's not a problem. For time reasons, we're moving on. So here's an example of where it makes sense to use a macro. If you're writing an assertion function for a testing library, it would be really nice if someone could just use the operators in your assert statements rather than having all these various versions of your function that someone needs to remember as well. And it would also be really nice if we're able to actually return not only what went wrong, but also show here, this is the code that we were actually trying to test here. So this is how one could write this as a simple macro. We pattern match, oh, I'm going to quickly to my slide. We pattern match here on, in this case, the greater than operator with the two arguments. And then we return some new AST where we put in this left-hand side and right-hand side as arguments. And we evaluate both of them and then check if the assertion is actually true. And if it's not, we're able to output some information, including here a nice string representation of the expression that was just passed in. And then, of course, we can do the same thing for all the other expressions that our assert function should be able to work with, and raise a compile time error in the case someone tries to write something that we cannot handle. What you can also do with assertions, with macros, what you just saw was a very, very simple example with a DSL where you can reuse normal Elixir queries or Elixir statements, and it does something else too. Two other very well-known examples within the Elixir community are Actos queries for relational databases and how Phoenix, the well-known web framework, does its HTTP routing. And these allow safe information of values, creating a very high-level data-driven, domain-specific language that allow a more efficient and more safe implementation, and in many cases allow to give you back errors at compile time that you would otherwise only catch at runtime. So these are the two main tools that you can use to change how code is compiling into your program. Now for the other part, compiling code or recompiling code at runtime. And this is not Elixir specific, back then, and in some cases still is, to power phone switches, which really need to be have a very, very good uptime, be available all the time. And they have this great advertisement video of now 34 years old, where they explain how they're able to call each other and use this software that does this phone that manages this phone switch. And when one of the calls breaks, they're able to fix the bug, coordinate over the other calls, and deploy a new version of their software without any of the other calls having to be brought down. And this is not only nice for this particular example, but also really nice when working with certain types of web applications where it's really important to be able to still access your current data and memory or have these connections to other services open all the time. It also really helps while writing and debugging your software in the console, because if something goes different than you expect, you're able to make quick changes to your code, recompile that particular module, and all your data is still there. You don't have to refresh anything, any part of your data. It also really helps here that Elixir is a functional language with immutable data types. But now for some other examples where hot code reloading really makes sense, besides being able to deploy new versions of your software without stopping a program. One example, which is by some people called a little bit of a hack, is known as fast global, and nowadays there's also a built-in version of this persistent term. Because for most cases, it is fine if you store your data in a single Elixir Erlang process, and when another process needs to read this to coordinate with this process. However, all memory in Elixir Erlang processes is completely separate from each other. They're not able to immediately access it. And this means that in some cases there might become congestion on certain processes that have certain data. And there are some other ways to resolve this, for instance using ETS, Erlang Term Storage, but even that has at some point its scalability issues. And one thing you can do to fix this problem is to actually recompile data into a piece of code that is then shared between all the processes again. Of course, there are many cases in which this doesn't take sense, so benchmark before you use it. But if you wanted to build something like this by hand, it would work like this. We have a simple module with a get and a put function, and in the get function we check if any value was already stored, and if so we return it, if not we return a default value. And when putting a value, we evaluate some AST that we're building here at runtime. And here we define a module that has the given key as module name with a single function that contains only the value we're interested in. Of course, don't write this code at home. Nowadays, starting in OTP 21.4 or whatever the version exactly was, there's a built-in way to do this using the persistent term library that now ships with Erlang itself. And again, this is somewhat of a hack. You only really need this if you have efficiency problems. But let's look at another example. TZ data is a very widely used library for keeping track of time zones, because how time zones and daily summertime, wintertime is handled, daily savings time is handled, changes between countries, but also sometimes how this within a country is handled changes based on political decisions. Sometimes we only have like a week notice before it happens. And so it really doesn't make sense to pre-compile your program only to have the time zone information change and then you have to do it all again. So it makes sense if this happens outside of your normal program release schedule. So what TZ data does is at runtime, once a day it performs a request to a remote location where the time zone database file is stored. And if there are any changes, it recompiles that information into your application. Currently it's actually still using ETS, but there is work being done right now to replace this with persistent term exactly for the scalability issues that they're facing. Another very interesting application of this is using introspection. There are many languages and environments in which when you want to find out while your application has a memory leak or is behaving in an unexpected way in the wild, you have to stop the program, add some tracing statements to your source code, recompile it, start it again, and then hope and pray that the program will trigger this same weird edge case. However, in Elixir and Erlang, you're able to actually patch this tracing information into the calls where you want it, and the rest of your program is completely unaffected. So in this case, we start with the same Fibonacci example as before, but now when starting an introspection debugging statement where we say we're only interested in calls to the Fibonacci function with 1 as an argument, then that call to the tracing functionality is only used over there, and the rest of our application still works exactly as it was before. Now, when we call it, we immediately receive all these tracing messages, so we can use that to debug, and once we stop, the tracing information is removed again, and now our program works identical as it was before we started tracing. So this really helps, for instance, when working with race conditions, etc., because all other parts of a program are completely unaffected, and this works because we're running on a virtual machine with bytecode. So there you have it. These are 2 tools you can use, and recompilation at runtime is maybe the slightly more archaic one and has more niche applications where you could really use it. But both running at compile time and recompiling code at runtime are very useful, and of course also share a lot of similarity between them. As a final warning, I would like to say that these are great tools and you can build some really amazing stuff with it. However, if you're going too far, then your code might become very hard to read or maintain, because if someone writes certain code and a macro completely transforms it into something else, then it becomes difficult to know what is going on. But of course, also very important is to have fun and to enjoy what we're working with. All the things I talked about have some information on the internet, which you can look at. My slides will, of course, also be available online. And with that, I want to thank you very much for your time listening to me today. Thank you very much. And now there's some time for questions.
Have you run any benchmarks in terms of comparing, recompiling the code so that you have access to terms in other processes, or sharing it to ETS or that sort of stuff?
The question was, have you run any benchmarks to compare putting stuff into ETS versus recompiling a module and reading from that module? I have not done myself. There are some benchmarks available of other people who did this for various different projects, and essentially recompiling something of course takes a lot of time, and also the more processes you have, the longer it takes, because all the processes will need their code store refreshed. However, once it is stored, it is a lot faster and a lot more scalable than ETS, but only at very large scale. So for most applications starting out, it really makes more sense to first start with an agent and then at some point with ETS, and only when you're really reaching the limits of that, start looking into persistent term storage. Yes?
Do you have any advice on how to test code that uses macros?
Do I have any advice on how to test code that uses macros? Well, I have written some libraries in the past that used macros, and something that really helped me while debugging is that after creating my AST in the macro, to just put an IO inspect statement there. And there are some helper methods as well in the code module that Elixir ships with that allow you to introspect your macro, your AST as readable source code again. And that really helps to find out what exactly is going on there. And besides that, try to come up with a lot of examples of what you want it to look like when someone uses the DSL that your macro provides. Also try to come up with counter examples of things that people might try, so you can test for common errors. And of course, I'm a big fan of using property testing wherever it's possible, and that might also really help to catch some edge cases that you would otherwise not have considered. Great question, thank you. Yes?
It's, well, looking at your resources, great list of resources, but there is one great book by the author of Phoenix about macros. And I forgot the name of the author of Phoenix and the name of the book.
Better programming with
Pretty cool book.
Great, I have not read it myself, but it's probably a great resource because Chris McCord really writes very well. Thank you for mentioning it. I will add it to my slides.
That's it then. Thank you.
Thank you very much.